Cool. Let's talk about inheritance. I'm just going to get right into it today. So we want to talk about Scala's type hierarchy, which of course we want to talk about inheritance and everything. But I want to talk about this picture here. We have these types that we've been working with: double, float, long, int, short, byte, unit, boolean, char. All these types extend any val. And then we have everything else, including every class that you write, extends any ref. And anything that extends any val is going to be stored on the stack directly. We work with values. Any val, short for any value. We work with values of those types. Anything that extends any ref is going to go on the heap, and we're only going to work with references. Any ref, short for any reference. We're only going to work with references of those values. And any val and any ref both extend any. What does this even mean, to extend a class? Well, this is where inheritance comes in. Extending is the same as inheritance. When you extend a class, you are using the concept of inheritance. But those words don't really make sense yet, so let's talk about it. And then I'll bring this slide back up. I'll bring this chart back up at the end of lecture, at the point where we will be able to understand what's going on here and what this means. And let's do this by example. If I just say this is what inheritance is and give a really technical definition of it, it's one of them topics that just doesn't make sense that way. So I'm jumping right into an example. We're going to build some features of a game. For those of you not super into games or anything, sorry, quite a few of my lecture examples are games, for what it's worth. But we won't build this full game. We're just going to talk about some of the mechanics and use this as an example to talk about inheritance. We won't actually build out the whole game, but I'll use this as an example. So this game is going to be a 2D top-down view. The player is going to have an overhead view of a 2D space. There's going to be players that can move around in the game. They're going to have health and strength attributes. And there are going to be two different object types the player can interact with: dodgeballs and health potions. The player can pick up dodgeballs, throw them at other players to damage them. If you yourself get damaged, you can find a health potion, consume the health potion, and restore some of your health. So that's the basic idea, the basic mechanics of this game that we would want to build. And for this game, there are three different objects that we want to make: player, dodgeball, health potion. So what I want to talk about is first talking about objects and classes, doing some review, because we need to know the hell out of objects and classes before we start talking about inheritance. So I just want to make sure one last time that we got the object and classes stuff down. Before we get into that, I'm going to use one bit of new syntax, and you can see this in the examples repo if you want to pull the code and check this out. But I'm going to start using this class called physics vector. This is a way to store three values, x, y, z, which I'm going to use for locations primarily in this game, to figure out where players' health potions and dodgeballs are in the game world. I'm going to use new syntax for this, and I'm going to start sprinkling in like little syntactical things here and there. You're at the level of 116. I assume that you're ready to see some new tricks and just things that cut down your typing and just cool things that you can do in programming. So I'll start sprinkling those in. This is the first time I'm doing that. Maybe not the first time, but I'm going to start doing that here. I guess the first time was plus equals, that shorthand. If you're not okay with the shorthand, you just don't like it, you want to go do things a more straightforward way, it's perfectly fine. But if you want to start using shorthand, I got some for you. This one is default values in parameter lists. So the constructor of physics vector is going to have these equal zeros for each parameter, which means if you don't specify all three parameters, the ones that you don't specify will get their default values. So when I say new physics vector of 2, -2, but the constructor takes three parameters, this usually shouldn't be allowed. you should get an error that says, hey, you didn't give me 3 parameters, you only gave me 2. In this case, x is going to get 2.0, y is going to get negative 2.0, and then z, there's no argument for z, so z just gets its default value of 0, 0. Sometimes I also do new physics vector with no arguments. That's going to give me a vector at 0, 0, 0. So if I want something that's just at the origin, I'm just going to say new physics vector, open paren, close paren, not provide any of the 3 arguments, and get my 0, 0, 0 vector. Just a word of caution if you do start using this, be careful with your assignments. My submissions in AutoLab will not be using, or may or may not, I guess sometimes I do, but may or may not be using this syntax. So if, say, in your item class you give a default description and a default price, and then in your test you say new item, open paren, close paren, that's going to be fine for your testing, but when you submit to AutoLab, you'll be creating a new item without the required parameters where I don't have any default parameters, and you'll get error running your tests on my correct solutions and my incorrect solutions. So just a word of caution about that. But whenever it's not being used in your test cases, like if you want to use this in your code itself, it's perfectly fine. And of course, outside of the class, when you're not submitting something to an autograder. Any hint on how we test set base price? Call set base price, then call price, and make sure price returned the base price that you set it to. So I'll use this. So when you see new physics vector with 2 values, that means I have a z of 0, 0. Since this is a 2D game, a top-down, I don't really want to use z at all. So I'm going to have a bunch of physics vectors that just have two arguments. And all this made maybe not more sense, but it was more familiar. I haven't ran it in a while, but Homework 1 a long time ago, like 4 semesters ago, I want to say, used to be building a physics engine where you're updating physics based on their velocity. It's a 3D space with gravity applied and collision detection. I haven't ran that in a while. It's kind of an intense assignment, especially for Homework 1. But that was in a 3D space, so we used these Z's. For this example, I'm going to use the same class, but we haven't used it to begin with, so it's not as meaningful, I guess. But for what it's worth, that's my physics vector that I'm going to use throughout the examples today. Let's get back to our game. And you can see I'm going to start using physics vectors all over the place. Let's get to this game and build the state and behavior. I have these 3 objects, and I need state and behavior for all 3 of them. And I'm going to make up, what I would want for this game, what state and behavior I'd want for my objects. So for the player, I want the player's location. Makes sense. I need to track where that player is in the game world, so I'm going to have to store its location. I also want to store the player's orientation, which is which way they're facing in the game. So when a player throws a dodgeball, I need that information in my code to know which direction that dodgeball should fly in. So I need to know this player's orientation as well, just so I'm not throwing dodgeballs like always in the same direction, no matter which way you're facing. That'd be a little frustrating to play. So I need this information. Health and max health, we saw this in a previous example. We have a game where players can be damaged, so health and max health just makes sense to have. And finally, strength is going to be a stat which determines how hard a dodgeball is thrown when it's thrown in this game. That's the state that I want for a player. And I also have 2 pieces of behavior, use dodgeball, use health potion, which for the functionality, I'm going to defer to the dodgeball and health potion classes. Use dodgeball takes a dodgeball, and I'm going to call use on that, which we'll see on the next slide is going to take a reference to a player as a parameter. So I have to give it an argument, which is a reference to a player, and I want it to be a reference to the player that's throwing the dodgeball. Well, I have access to that. If this use dodgeball is being called through a player, this is a reference to the player that's throwing that dodgeball. I can use this just like any other variable, and in this case I'm going to use this as the argument of a method call. So I'm going to give use a reference to this, the player throwing the dodgeball. The dodgeball is going to get a reference to that player, and then do its thing. It's going to get thrown. It's going to run its code that determines that it was thrown. And same with health potion. Hey, health potion, this player is using that potion, and the potion can do its healing thing, running its healing code. Thinking of the state and behavior of a dodgeball. The state, I want to know its location, but I don't really need its orientation. I'll take velocity instead. Velocity, it's a vector, it's going to have a direction. With that velocity, I know which way this dodgeball is moving. So I don't need the orientation that we had on a player. And I'll take the mass. I want to know the mass of this dodgeball. If I want dodgeballs of different weights that are going to do different amounts of damage to players when they collide. So the XY, this would be a player at location 2, -2 in the game world. Let's see if I can try to visualize this. And they're going to have an orientation of 5, -5. So the location is where they are physically. The orientation is which direction they're facing. Not crazy relevant to the discussion of inheritance that we're leading up to. So if you're not keen on that, that's not the biggest deal. If the example is there to just give an application to the concept, as long as you can get the concept, that's what we're really after. But that's what the location orientation would be. And they're both vectors. What's the function used at this? That's what we're talking about here. Everything is a vector. So the vector stuff, this is why I haven't ran the physics engine in a long time, because the vector stuff freaks people out sometimes. There are I don't know about quite a few, but at least a decent number of students who take 116 and haven't taken any physics classes before. Not everyone takes high school physics. Not everyone chooses physics for their requirements, for their science requirements. And then they get to physics engine, and I'm like, oh, y'all know what vectors are. And a good number of students each semester say, no, I don't know what a vector is. So if you don't know what a vector is, don't worry. It's just one lecture example, not an entire homework like it used to be. And it was bad. I listened to the complaints and changed it. Rhyming dictionary, like y'all, or no, we don't do rhyming dictionary. Pale blue dot. We all live on Earth. We know what cities are. Maybe you haven't seen lat long or really worked with lat long before, but that's something I got on a tangent here, didn't I? If you're in programming for long enough, you're going to be coding with lat long. It's just something we're all going to deal with at some point. You'll want to work with locations on the planet, and lat long is the way to define a specific location on the planet. So that's something, even if you haven't seen before, I want you to get in practice with, because you're probably going to see that again throughout your careers. Anyway, I got to end that tangent. Location, velocity, mass, and the use method that we saw on the previous slide. So I have a reference to a dodgeball. I call its use method, and I pass a reference to the player who's throwing that dodgeball, who's using that dodgeball. On the other side, in the dodgeball class, this is the method that we called there, takes a reference to a player, returns unit, and to simulate throwing the dodgeball, we're going to set the velocity of the dodgeball in relation, based on a function of the player's strength and orientation. So the way the player is facing, and then take their strength into account, so I know how hard they can throw this dodgeball. And if I were to modify this and I were really building this game, I'd want to factor in the mass as well. It's weird that this player can throw any mass of dodgeball the same velocity. That's something I would add if I were building this out. I would do like strength divided by mass probably. But we have some way to set the velocity when a dodgeball is thrown by a player, or use as the general verb. Health potions, I want the location. I want everything to have a location in my game, and the volume. I'm going to be unitless on my volume, so I'm using something called physics vectors, but the physicists would be pretty upset with me because I have no units anywhere in this thing. All these units are made up units in my game world, but I'll say the volume of a health potion is going to be exactly the amount of healing that it can do. So I have a potion with volume 3. I'm going to say that potion can heal 3 hit points when it's consumed. And here's the next kind of shortcut, but really just like feature of Scala that you can start using is I want to heal the player the amount of volume, so I'm going to set this player's health equal to their health plus the volume, but I want to make sure they don't go over their max health. So I'm going to use the min method. Remember, everything in Scala is an object, which means everything in Scala has state and behavior. Part of the behavior of the int class is this min method, which is going to return the min of the integer that called it and the argument that you give it. So in this case, if I overhealed with this potion, min is going to return the player's max health, and the player's health is going to be equal to that. If we didn't heal fully, then this is going to be the min of the two values, and that's what's going to be set to the player's health. So I can get quite a bit done in one compact line, which you might want to start doing at this point. If not, the 115 way of doing this would be if player health, you would use a conditional. You would say if player health plus this dot volume greater than player.max health, player.health equals max health, player.health equals player.max health, else player.health equals player.health plus this dot volume. So it'd be a bit more verbose. It'd be a bit, be 5 lines of code with your parentheses and everything, but it'd work just the same. So if you still want to code things that way, it's perfectly fine. I ain't going to stop you, except on the homework, because that would use a conditional where this wouldn't. But the homework doesn't put you in a position where you'd want to do this specifically. But useful stuff to start cutting down your typing, if you're into that. If you're not, that's perfectly fine. But I would argue that this is more legible as well. Like I can read this line, once you're used to seeing this call here, I can read that line of code easier than that big conditional. It would take a little bit of time to parse through that conditional to figure out what's going on. Yeah, the orientation should always be a unit vector, which I didn't do. I noticed when I was explaining that on the slide, I'm like, why didn't I make this a unit vector? Not relevant to our conversation about inheritance, so. When are we going to release the dodgeball game with perfect physics? I could release my solution to the physics engine code. I do have a game that uses the physics engine code. I could release that since I'm not running it again. This dot, I think I missed the question about velocity where I used this dot velocity. I used var there, unless you're ahead on the slides. Oh, no, I see what you're asking. So, and in general, you can do this. I don't have to say this dot velocity. I can just say velocity and then let my scoping rules kick in. The problem with that, and in my slides, how I always put this dot, unless I forget, is if I just use velocity and there's a variable in a more inner scope, like if this method takes a velocity or I have a local variable that I declared named velocity, then I'm not going to get my state variable velocity. Those scoping rules apply and will overshadow my state variables. So that's one reason why I like to do this dot every single time, even when it is technically optional. This hasn't come up in lecture yet, but it is technically optional that this dot. So one reason is scoping. Make sure you're getting your state variable. And 2 is readability. If I say this dot velocity, it's 100% clear that I'm modifying the state of this object. If I just do velocity equals, then it's not immediately clear to either yourself reading your own code or other developers reading your code, hopefully not in this class, it's AI and all that. But when you get out there in industry, you're going to be working on a team. You want your teammates to be able to read your code easier. If I have this dot velocity, 100% clear, I'm modifying the state of this object. Velocity equals new physics vector, not quite so clear. There's an extra step that the reader has to take to know that that's modifying the state of the object. Or you're using an ID where it highlights it like this. The state variables are all in different color. So whenever you see this italicized purplish, maroonish, I don't know what to call that color, but whenever you see that, you know you're accessing a state variable of an object when you're using IntelliJ anyway. Okay, but there's a big problem here. This is a super boring game. Not just when it's fully done and working, you know, you might still agree that it's boring. But this game, as we defined it right here, with objects, means that we can only have one player, one dodgeball, and one health potion. We can't have any more of those. We got a single player game with exactly 2 objects. Can't really do much here. I can go find the dodgeball, pick it up, throw it, go walk over to it, pick it up again. Maybe I'll try to throw it up against a wall and have it bounce back and hit myself if we have all that built in the physics engine. Then go drink the health potion and do it again, I guess. I don't know. I'm not gonna have much fun playing this game. This game's only fun as a multiplayer game, and I'd want multiple dodgeballs, I want multiple health potions, and that's why we use classes. So we're going to define these as classes so we can create many objects of these types. I want a player type of dodgeball type, a health potion type, and then I want to create many, many objects of those types. So I can have a multiplayer game, multiple dodgeballs, multiple health potions, make it at least a game. Like, you might argue that it's still a boring game. That's fine, but it's going to be a game at least. It's not going to be one player, you know, singletons. So in Scala, when we create things using object, when we had object, there can only be one of them. Those are singletons. There can only be one health potion ever. We use classes, and we're going to rewrite these as classes so we define a type and create multiple objects of that type. This is why we learned classes last week. So when I create my classes, when I rewrite these as classes in this case, or when I'm just creating my classes to begin with, I'm thinking about, I have one big question that I have. When I'm thinking about my state variables, I want to know which ones should I put in the constructor as parameters and which ones should I put in this code outside of all the methods. Which should go where? And the big question, the big answer to that one is, what do I want people to be able to initialize when they create objects of this type? When somebody creates a new player object, what should they be able to initialize? Which is what's going to be different for each player that's created. So location, absolutely. I want more than one spawn point in my game, so the location should be set in a constructor parameter. Orientation, a little more debatable, but I'd say I want this to be set for each player. If I have multiple spawn points, say I want to spawn in this corner, I want the orientation to be this way, facing the game world. I don't want my players spawning in facing towards a wall. I have another spawn point over there. I want them facing that way. So I'm going to have different orientation based on my different spawn points. So I'm going to put that in the constructor as well. Let whoever's calling this constructor, whoever's creating player objects, let them decide what the initial location and orientation is. Max health and strength, these stats, maybe I want different classes in my game. I want somebody to be an archer. I want somebody else to be more of a magic user, thinking ahead to new features we would add to this. But I'm going to want different classes in my game. So maybe some of them will start with more health than others. Maybe some will have more strength than others. And I want the constructor, the people to be able to set that when they create new players. One variable that doesn't make too much sense to me to allow them to initialize in the constructor is health. This is going to work the same way no matter what. Like, no matter what, when a new player is created, I want their health equal to their max health. I want everybody starting my game at max health. It'd be a strange feature to have some players spawn in already damaged. Maybe that's a feature you want in a game. Maybe there's some interesting way that makes that make sense. I don't really think so. For this game, at least, we're going to start everybody at max health. And the behavior doesn't change. Behavior is the same. So dodgeball, location, velocity, mass. Well, I want all of those to be able to be initialized through the constructor. So you're going to have to specify everything for a dodgeball. All goes in the constructor. And health potion, location, volume, all of the behavior. I'm going to throw it all in the constructor as parameters. So we can have different mass dodgeballs. If not, I wouldn't have had it as a variable, a state variable at all. I would have just had that hard-coded into the dodgeball class. That's what its mass is going to be. And volume, I want health potions of different volume. Maybe you want them all to be the same. If you want them all to be the same, again, you just wouldn't have it as a state variable at all. You would have it hard-coded, this dot volume. You would have that as some fixed value, preferably stored in a constant, but not going to get into that too far. But magic numbers and all that. But you would hard-code that. If I'm putting it in as a state variable, I'm going to let the caller of the constructor set that value. Now that we have classes, we can have multiple objects of these types. I'm going to create new dodgeballs, give it the location and velocity, the initial location, initial velocity, and mass, initial location, initial velocity, mass, and I'm going to get two different objects on the heap. I'm going to have references to those objects. And those objects each have their own copies of all of the state variables, which can be different across the two. It wouldn't make sense for every dodgeball to have to be in the same location in my game. I want different dodgeballs at different locations, so we create a class, create objects using that class, and now I have multiple objects on the heap with their own copies of their state variables that can vary independently. What do you mean by constructor? So the constructor is defined right here. This is a method called the constructor. And this is the method that we call whenever we create a new object of that type. So I'm going to say new and then call the constructor. And that's going to return a reference to a new object that was created. All right, any questions on this? So this was review from last week, but I want to make sure I put an exclamation point on the classes and objects discussion, because we can't really go forward with inheritance unless you got classes and objects down frickin' solid. So any questions on this? Will Jesse release the instruction code after class? It should already be in the repo. Unless, I don't think I missed it, but it should already be in there. With OP, yeah. Yeah, it's in there. Some of the things you might have to dig a little bit for, but... Actually, this might not be the latest version of the code. Oh, yeah, it is. Any questions on classes, objects, references? Yeah. Oh, you asked, can you explain player? So, yeah. This guy right here. So this means that this method as a parameter takes a reference to a player object on the heap. So I define the player type right here. Once I define that type, whenever you create a class, you're creating a brand new type. So I have this new type named player. And now I can use that type wherever I used to use ints, doubles, lists, strings. I'm using that type as a parameter for this method. Cool. And same thing right here. I'm using dodgeball and health potion. Without those dodgeball and health potion classes being defined, this wouldn't be valid code. But once we define dodgeball, the class, which defines dodgeball, the type, health potion, the class, which defines health potion, the type, now I can start using those types wherever I would use ints, double strings, maps of strings to ints, etc. Yes? They can appear anywhere. So typically, you'll have your classes in separate files. Like these classes would be in 3 separate files. And as long as you are in the same package, then you can just start using them. And if you're in a different package, like when you were in your test package, you had to import pale blue dot, hit your import statement, and then make sure you import anything that you need, and then start using them. But the order isn't important. Whereas like C++ would care about the order, and you get all kinds of crazy errors because you got things declared in the wrong order. Scala is more generous with that, and let's just define things all over the place and just start using them. Yep, no problem. Difference between class and object. You use classes to create objects, would be my short answer to that one. But you don't actually use, we're only interested in objects, but we create a class to be able to create many objects of that type. We create a player class so we can create a bunch of player objects. Yeah, I like that answer. A class is like a factory that makes objects. There's something comparable to a switch statement in Scala. Yeah, it works a little different, but it's a match case statement. The difference is that it can also check types, which makes it very useful. When we're using this, are we referencing the class? When we use this, we're referencing an object. So this is an object of type health potion, and it's the health potion that called this method. But it's a reference to a specific object, not the class itself. We won't reference classes themselves, I don't think at all in this in 116, but we will reference objects of that type. This is a reference to an object of type health potion. I guess the only time we really, I guess you might call this referencing the class, we're calling the constructor defined in the class. Then after that, we have a reference to an object. What class does the dodgeball object belong to when dodgeball class is not defined yet? So when we did so we wouldn't use the dodgeball object, like object dodgeball. Like object dodgeball, we won't actually use. Maybe that wasn't completely clear in the lecture, but we wouldn't use this. This is an example of if we were just to say, I don't feel like learning classes, I'm just going to use objects for anything. This was the pitfall you would run into. If you use object here, you get a game. You get a single player game with one of each object. We don't want to do things like that. So we rewrote it using classes. And these classes would be defined without those objects. The object code wouldn't exist. We wouldn't actually do things like that. We want to use classes instead of object. This does get confusing. It's unfortunate that Scala calls this object, because it gets confusing of object like this or an object that I created using a class. What we want to do is, from really this point forward in the semester, from last Monday forward, is never use object. We're always going to use classes and then create objects using those classes. We wouldn't actually use object dodgeball. we'll use class dodgeball and use that class to create objects by saying new dodgeball. It's unfortunate that Scala calls it object. I wish it would say like singleton dodgeball. It would make it much more clear. It would be much more clear what's happening because we reuse the word object. So object has two different meanings in two different contexts. I create an object by putting object dodgeball, or I create an object by saying new and then call a constructor. We overload that term in Scala, and not a super fan of that. All right, any other questions? We've got good questions there. We want to talk about inheritance. Okay. So let's start with an observation. Dodgeball and Health Potion have quite a bit in common. I mean, they don't have a ton of code as it is, but the code that they do have has some similarities. They both have a method named use that takes a reference to a player and returns unit. And they both have a location variable. And we can think of a lot more that they'd have in common. Now, I'm always trying to fit things on the slide, so I don't have these classes too huge. We'll grow them a little by the end here, but there are other things that we could add to these classes. Dodgeball already has mass, but we could think of a way to have Health Potion compute its mass based on its volume. We might want to compute momentum. They both have, actually Health Potion doesn't have velocity, but we could give Health Potions velocity and then use that mass and velocity to compute momentum. And we might want to define what they do when they hit the ground. When a dodgeball hits the ground, we want it to bounce. When a Health Potion hits the ground, we want it to shatter and be removed from the game. Like we can start thinking of more ways that these two classes would be in common. Whatever we want to have happen to any of whatever state and behavior we want for any of our game objects, there's going to be a lot in common there. So with inheritance, we're going to take that common state and behavior and factor it out into another class and define any common state and behavior between the two objects in this third class. So I'm going to create a game object class where I'm going to put everything that these two classes have in common. And then each of these two classes will extend game object. Whenever I say extends, you can think of that as inheritance. That's extend is the key word in our code. It's going to allow us to use inheritance. Dodgeball and Health Potion will extend game object, which means that they each get all of this state and behavior from game object. They have these state variables, well, this state variable, these two methods, and we are going to add object mass here. These two methods, they get that state and behavior, and then in addition, they're each going to define any additional state and behavior that are specific to those objects. Velocity and mass are specific to dodgeballs, and volume is specific to Health Potions. So we're going to write our game object class. And again, this will go in a separate file. I'd create a new file named gameobject.scala and put this new class in there. This is going to be an abstract class. So an abstract class is a class that's only partially defined. I cannot create objects of abstract classes. We can see that we have these two methods that don't even have definitions. It's like I didn't even finish writing this class. So we call this abstract, and we cannot create objects of abstract classes. I can never say new game object and call this constructor. Because say I did allow that. Say I allowed somebody to say new game object of some physics vector, and then I said that game object dot object mass. What do you expect it to return? I have a method that doesn't have a body, and I call it, what's going to happen? The answer is we just can't allow that. We're not going to let anyone do that. So you can't create objects of abstract classes. So I have an abstract class which is a partially defined class, and its whole purpose of existing is to extend or inherit this class from other classes, finish defining the classes, and then those we call concrete classes, and we can create objects of those types. We have two methods here, no definitions, no bodies. These methods are called abstract methods, and if you have at least one abstract method in your class has to be abstract. Because what are these methods supposed to do? So we can't create objects of type GameObject. We can't say new GameObject and call this constructor because it is an abstract class. It's not fully defined. So what do we even do with this thing? We're going to extend or inherit GameObject. So now in our dodgeball class, we're going to remove anything that's common between dodgeballs and health potions and move it to GameObject, and then rewrite our class with all of that functionality already inherited. Now, of course, for this example, you're going to say, well, look, we added code and didn't add any functionality. And you have a valid point. I'll get to the reason we want to do this in a minute here. But we're going to say class dodgeball with our constructor as we always had. This we've always had before. And then we're going to say extends, which is inherits, GameObject. So I'm extending this class. I'm inheriting all of the state and behavior of the GameObject class. And whenever you extend a class, you're going to call its constructor. So I have to call the GameObject constructor, give it any arguments that it's expecting, and I have as my choices in scope all of the parameters for the dodgeball constructor. So I have my location, which I'm taking as a parameter. I'm going to forward that parameter to the GameObject constructor and use that as the object location variable in that constructor. There are scoping rules that apply when you have multiple constructor calls like this. So these all become state variables. That much Wednesday will be a giant memory diagram, so that much will be more clear on Wednesday. I'll save that conversation for then. But all of these three and this, all these variables become state variables of dodgeball. So if I said location and reuse the name here, which one is in scope at which time? It gets complicated. With code blocks, the scoping rules are more straightforward. I can show you how that works, ask you to do that on the quiz and talk about it on the interviews. The scoping rules for this are way too complex. It took Paul co-teaches this course with me in the spring. Paul and I in a room of TAs about an hour to kind of have a grasp on how these scoping rules work. Like we got there, we understood how it worked, and we both looked at each other and said, there's no effing way I'm covering that in a lecture. It'd take up like a whole lecture just on its own. So just name these different things. Just name them different things, and we won't worry about scoping rules for those. That's my agreement to you. We just won't worry about it. I won't put it on a quiz with multiple, the same variable name being used multiple times. We just won't talk about it. And then we have these two methods that we didn't define in the abstract class. And now it's time that we have to define them. When we define these methods, we're going to use the keyword override to say whatever override is saying, hey, I got a method named objectMass that returns a double from a class that I'm inheriting from. I inherited this method, and now I want to override whatever that method does, and I want to change its behavior to this. Now, I could actually define objectMass in the abstract class. Abstract classes don't have to have abstract methods. You can have a mix of abstract and non-abstract. So I could define it here, and override would say, whatever definition is here, replace it with this definition. So we're going to override these methods that we inherited with behavior specific to this class, the dodgeball class. I don't want the behavior of the game object class. I want dodgeball-specific behavior. And we'll do the same thing with health potion. So these methods are going to have very different behavior, but they're both going to have the same parameters, return type, and name, which will be very important moving forward. So very different behavior from the same methods. And this is how we can start getting different behavior, a little foreshadow to how you're going to do task 3 without conditionals. We can get very different behavior from the same method call. I'm going to call object mass and expect a double to be returned. I can get very different behavior from that method call based on the type of the object that I called it on, whether it's a health potion or a dodgeball. So we can get very different behavior without using conditionals, just depending on type instead of value. A conditional is going to check a value and then run code conditionally, but we can do the same thing with types. That's all I want to say about that for now. We'll get into how to really leverage that when we start talking about polymorphism. But why? Why are we even learning inheritance? Especially for the example I showed, it was more work for the same functionality. We haven't seen any payoff yet. We'll see some now. Personally, I think the big payoff is when we start talking about polymorphism, but we have some payoff that we can get right now. So what if there's some method that we want to add to every type of object in our game? Dodgeballs and health potions, I want them to all have this extra method, and I don't want them to override it. I just want the same behavior from both of them. Well, we can just define that in the game object class. I can define a method, a good bit of code, and just automatically get this method in every health potion and every dodgeball. Every health potion and dodgeball will automatically have this close to player method because it's defined in game object. They all inherit this method. Now you could write this once, write it in health potion, copy it, paste it in dodgeball, and that would work. Like, you get away with that. But that's going to be very hard to maintain. As we want to start thinking of large programs, what happens when your programs get really big? Well, what happens when you want 100 different types of objects in your game? Well, if you want bow and arrows and swords and grenades, what if you want to add all kinds of different things to this game? Well, each one, you're just going to extend game object, inherit all the behavior that's common to every game object, and then only define the specific behavior for that type of object in that class. So when I have hundreds of subtypes, I'm going to add code to game object, and that applies everywhere. But we can also take this a step further. So we can have chains of inheritance. So game object, let's just pretend that we did the physics engine as homework 1. And physics engine works with physics objects, and it updates velocity, applies gravity, detects collisions, all that stuff. But it needs physics objects. Well, let's take our game object, extend physics object, call its constructor, and now my health potions, my dodgeballs, my bow and arrows, now they can all have physics applied to them. I just throw them all at my physics engine. They are all physics objects, and I can have physics in my game without changing a single line of code in my game objects, in my health potions, none of that. I don't change any of that code, and I get physics almost for free after I write the physics engine, of course. But the physics engine and my game logic don't need to interact, don't need to know about each other in the code. I just extend physics object, and it just all works. So our inheritance diagram, our type hierarchy looks like this. We have health potions and dodgeballs, which extend game object, which extends physics object. And this is how we write that out visually. Brings us back to this chart. So we're right here, your class. All of this goes here. And if you don't explicitly extend any class, you implicitly extend any ref. So any class that you write that you don't use inheritance is automatically extending any ref, which extends any, which means your objects are going on the heap, and you only have references to them, and everything else is going on the stack, values on the stack directly. Yeah, so if I have an abstract class with def x returning 6 and override it with returns 3, the new x would be 3. Yes, in that type where you overrode it. And you can overwrite it in different classes with different return values, and it would depend on which type you created, what would be returned.